Hello, everybody. Welcome to our panel on quantum computing and gaming. I'm the lead writer for GamesBeat at VentureBeat, and I've been covering games for about 24 years or so. And I've also covered the tech industry for close to 30 years. And I very rarely have seen these words together: quantum computing and gaming. And so this is kind of a first for me, and very interested to hear how those two worlds converge for our panelists. And I'm going to have them introduce themselves now. And let's start with Christopher Cantwell.
Hi, I'm Chris Cantwell. I am a former grad student in quantum computing. About 5 years ago, I created a game that eventually became quantum chess, and I have since started a company called Quantum Realm Games, where we're setting out to push quantum chess to the next level and develop other games that have quantum mechanics as a core gameplay mechanic, as well as build tooling on top of these things for education and outreach.
Mm-hmm. And let's go to James Wootton.
Thank you. So I'm James Wootton from IBM Quantum, and I work in the education team at IBM Quantum and doing things that also are related to bringing the science behind quantum computing to the community. Both of those aspects I find that you incorporate games both as an educational tool and as an application that we're looking to use quantum computers for that will be interesting to many people.
Mm-hmm. And let's have Sabrina introduce herself as well.
Hi, I'm Sabrina Maniscalco. I'm a professor of quantum information, computing, and logic at the University of Helsinki and Aalto University. I'm also the vice director of the Finnish Center of Excellence for Quantum Technologies and the co-founder and CEO of Algorithmiq, a startup on quantum software. And one of the reasons why I'm here is that one of the things we like doing is working on quantum outreach and education. And therefore, we are launching PlayLearn, that is a platform that is specifically dedicated to education and learning in quantum science and technologies.
Mm-hmm. So my first question for everybody is just like, how did you get into this subject? Like, what brought games and quantum computing together for you? So let's start with Sabrina on that one.
Yes, this was, I think, about almost 10 years ago. So we started to think whether it is possible to use video games to solve research problems in quantum physics. So actually, I started not from the educational side, but really by developing toolbox. The quantum black box is the toolbox we have developed to solve real optimization problems for research in quantum computing. And we developed some games for this. Then we started to organize the quantum game jams. And that is the moment in which we actually met the gaming community. And since then, we organized every year quantum game jams, starting from 2014.
And James, how about you?
So a few years ago, I was at a conference, a local one, and there was a technology transfer officer for the funding body asking me if there's anything I did that could be like go to market, essentially. And as a theorist, I basically laughed in her face. But then I began thinking and realized that the research was suitable for a citizen science project where I could get people involved in the science around quantum computing. And then since then, I haven't looked back. And after that, I had actual quantum hardware to incorporate. So I've been doing that over the last few years as well.
Mm-hmm. And Chris?
Yeah, so a few years ago, while I was still a grad student, I took a course on creativity and invention. And as a final project for that course, we had to invent something. The professor of the course asked if, given my background in quantum computing, I could maybe come up with a game that would help people understand quantum physics concepts a little better. And so in about a month, I created a little prototype of a game that was built on top of a quantum simulation of, let's see, at the time it was 25 qubits. and showed it to my research advisor when it was done, and he put me in contact with Spiros Michalakis at Caltech's IQIM, and it kind of took on a life of its own from there and became quantum chess and everything that it is today.
Mm-hmm. So the two threads we see here is that there's a technology side to this, and quantum computing can help create new applications or new kinds of games. And then on the other side, there's this educational aspect where games are really kind of telling the story of quantum computing, I guess, right? So Chris, can you talk about the technology side, like what application of quantum computing do you see as practical for games?
So I really think that games give us a window into phenomena or experiences that we can't normally access in our everyday lives. One of those being quantum physics phenomena that are just very counterintuitive to people. And I think if we can build games that incorporate this on as a core gameplay mechanic, then we could really give people the ability to gain intuition about things like this. And if these games are then run on actual quantum computing hardware, one, it gives a sense of authenticity to the experience. But the other thing is, down the line in the future, when we have more advanced quantum computing hardware, we might be able to give more complex experiences that might not even be reachable with classical computers today.
Mm-hmm. So what do you mean by authenticity in this context? Yeah.
So take quantum chess, for example. Right now, I have my own simulator of essentially 64 qubits that is simulating a quantum computing evolution on those qubits. That is run on a classical computer. Over the summer, we ran this on Google's quantum computing hardware. And while it can be simulated on a classical computer, just the fact that it's running on an actual quantum computer is very exciting to people. It's something that resonates with not even just people in the quantum computing industry, but gamers and science enthusiasts. I mean, a large part of the chess community that's very interested in my game was super excited to see that it's actually running on future hardware right now. So I think that authenticity adds something to the game, even if it can be simulated classically.
Mm-hmm. I guess that's my question: is why would you want to do chess this way instead of the classical way? I guess is there an advantage? Or you get a faster version of chess or something? Or...
So when I set out to create quantum chess, I wasn't trying to improve on chess. I was trying to frame quantum phenomena in something that was familiar to a lot of people. Um, chess is one of the most widely recognized games in the world. Even if you don't play it actively, almost everyone knows what chess is and is at least familiar with the basic rules of it. And so, if you could frame or create a rule set for a game that is similar to chess on top of an actual quantum system, then it might be a little more approachable than, say, a quantum chemistry experiment or having someone try and just go and dive into the equations of quantum mechanics. It gives people the ability to experience things like superposition, entanglement, and interference without needing to know the math and without needing to become very familiar with quantum computing concepts, right? I mean, you can see a piece in a superposition of existing on two different squares on a board. That makes more sense than saying, okay, this qubit is both a 0 and a 1 at the same time. People can sort of wrap their heads around it a little bit better. You have entanglement in the game where pieces can move through other pieces that are in superposition and their states become dependent on each other. I've found that with our community, it's a lot easier for people to make intuitive judgments about what's going to happen in these situations when they have something tangible to base those judgments in, like pieces on a chessboard.
Now, James, maybe first, do you have any reaction to what Chris described here? And also, if following up on that, like what's your own view of applications that are practical for games using quantum computing?
Yeah, so I agree completely with Chris that having things put in a tangible way is a lot better for helping people to under them rather than just having them abstract. And it was cool to see them put it on the Google computer. But yeah, in terms of applications, I think that quantum computers are going to be good for things that, like in games, you have to have certain processes done very fast. Like you're querying them every frame. You're not going to use a quantum computer for those sorts of processes. Instead, you're going to need to find problems that can be done a little bit slower, but which sometimes come across very hard problems. So one area that I've been looking at is procedural generation, which is where you algorithmically generate content, which could be various kinds of things like levels or puzzles or the terrain that you're going to explore or the backstory of a character or the narrative. And so a lot of these processes are things that when you do try to generate these kinds of content, you do come across computationally hard problems, and currently people have to find workarounds for that. And it's something that's kind of in the loading screen, so it doesn't matter if it takes a few seconds to query a quantum computer on the cloud.
Yeah, I think the way I remember this, what probably a lot of gamers do, is when I was playing flight simulator games, and the terrain would pop in, right? It wouldn't be there, but all of a sudden you'd see a tree, and then another tree comes, and more trees come in, and sort of the more you're moving around the environment, these things are just procedurally generated, and I think that's the way maybe most gamers understand it, right?
Yeah. Exactly, and for something like Flight Simulator, you just want to make some nice terrain. But if you think of something like a level, you want it to be distinct when you generate a new one, but you also want it to be completable. So you have to generate things that are as different as possible while also satisfying certain constraints, and that comes into constraint satisfiability problems, which is one of the things that we can think that perhaps a quantum computer will be useful for.
Now, I think the problem with procedural generation to gamers has always been that it takes away from that realism when things are just popping in, right? I guess you would rather see them actually in the landscape as you go into that landscape, rather than have them sort of suddenly appear, I guess, right? I don't know if that has anything to do with an improvement that you could see happening with the procedural generation.
Yeah, I think that's probably an improvement in classical things is how to better deal with that. But part of it is due to the time it sometimes to procedurally generate content, and if you can find ways to do it faster. Well, I don't think we'll really find faster ways to do procedural generation, just better ways to squeeze procedural generation into the same amount of time that we already use. So you'll have better things pop in.
Okay. Yeah. And Sabrina, how about you? What's your own view of the practical application of quantum computing in gaming? What can it be used for, I guess?
Well, I think one of them is what I mentioned before, that is for research. This is citizen science, of course. But then we have what I like particularly, that is using games as a tool for educating in quantum physics. And of course, this is also what Chris was talking about. We know that quantum physics is a fantastic but very counterintuitive theory. And that's why we want to try ways also of communicating things and aspects like superposition or entanglement, which we do not encounter in our daily life. And of course, games are fantastic for this. We have developed a number of games which, again, incorporate, as in the case of quantum chess, these concepts, these laws of quantum physics in the game mechanics. And in this way, they teach of course, the peculiar aspects of quantum physics. So you can also learn them and experience them even if you don't play chess. So there exist many other games that you can obviously already now start playing. And for these, we decided that it would be fantastic to create a platform, an online platform free for everyone, Qplay Learn, that will be launched on the 14th of December, and then it will be available for everyone. And we decided to start with a quantum dictionary, because, people are listening, and there are a lot of news about quantum computers, and maybe they hear words like the quantum state or the quantum measurement or the qubit, and they don't know what it is. And we have a dictionary with all these terms, and if you check one of these entries in the dictionary, you will find the games, but also you will find videos, you will find educational materials, and you will also find the math and the physics. So it's quite complete. And the idea behind is really that because intelligence is diverse, we want to offer different ways to approach the beauty of quantum physics and of quantum technologies, and therefore to teach to everyone at different levels, of course. So that's the potential I see of games as a very of course, interactive, but also experiential tool for learning. Concepts that in this case are very different from our daily life, from our intuition. And of course, something which is extremely important is to have really to work in a team of educators, quantum scientists, developers, because it is not simple actually to correctly give the right meaning of quantum concepts without being misleading. Unfortunately, very often there can be misunderstandings on what these concepts are, and we would like to do it in a way that is playful, but at the same time very strongly connected to what is scientific correctness.
Now, the next question can be for anybody who wants to jump in here. Just raise your hand if you want to respond to it. But it seems to me that it's going to take a long time before quantum computing becomes like an everyday thing that the biggest commercial game companies are going to be using in some way, especially if classical computing is easier for them, and if they don't necessarily see the big advantage that quantum is going to deliver. But indie games, there are millions of indie game developers out there now, and they're often a lot more experimental. They work on smaller projects, and the budgets aren't as crazy. So I would expect that this is the way that quantum computing is going to sort of filter into the game industry. Does everybody agree? Anybody want to address that?
Yeah.
Okay, go ahead, Chris. Go ahead, Chris, first.
Yeah, so I just wanted to say, I mean, that's in the next iteration of Quantum Chess, I've actually partnered with an indie game development studio. And one of the things that we're working on is creating a Unity package that can sort of help handle all of the quantum simulation side of things for an indie game development, and some other indie game development studio, if they wanted to sort of delve into this themselves. I completely agree that indie games and indie developers tend to be more experimental, and that's, I think, where we're going to see most of these coming from. I think Unity is a perfect platform for that because they're kind of targeted at indie developers. I mean, they have a huge market share, and all of their tooling is built to really help indie developers create some great games. So, yeah.
And James, you also raised your hand there.
Yeah, so I think that indie developers are often people who do programming as a hobby. They're maybe not thinking about coming out of a game. They just want to experiment with a new technology. So people like that are interested to learn about quantum computing by programming. And like Chris, we are also developing tools in Unity because you want to bring these tools to where people are at, where they're using, where they're making games, and game engines like Unity are perfect for that.
And Sabrina, go ahead.
Yes. I totally agree with the others, and also with your idea of involving indie game developers. And indeed, that's why we wanted to launch the Quantum Game Jams. Quantum Game Jams, game jams in general, were born from indie game developers, and obviously they are very much populated by them. And this is the for us, it's been the interaction that has been the most fruitful. For example, the Quantum Black Box that we have developed for solving optimization problems is a toolbox that we give at the game jam, and it's a Unity toolbox. So it took some time, of course, because it runs a simulation. The simulation is obviously normally physicists program in Fortran. So actually, this is some sort of API to give a Unity black box in the game jam has been a process that has required a lot of iterations. It's not so simple, because you see there are a number of conflicting requirements very often when you want to bring together simulations of quantum phenomena and something that you can directly give to game developers, like a Unity box.
Mm-hmm. And if you're thinking about inspiring game developers to get more involved here, like what's a good way to do it? Like what are some maybe visions of the future or predictions that you might make that could get people interested in this subject and using the technology? Anybody want to take a first crack at that?
I'll go.
All right, Chris, go ahead.
Yeah. I mean, I think envisioning a future, a far future, where these truly quantum game worlds exist that people can interact with can be very exciting. Like I envision a VR world where there are objects with quantum state, and even maybe the player that has quantum state, that is non-trivial, that is possibly even more complex than a classical computer could simulate today. And then coming up with ways for the player in this world to interact with these things. I think one of the challenges there is, how do you then display that to the player? I mean, in quantum chess, UI and what we are showing the player has been a huge challenge. So it makes you rethink things like, okay, what is the player seeing? How is that even information gathered from a quantum state? And maybe you have to think about things like, okay, well, we're performing weak measurements of these quantum states and translating that into some visual representation that makes sense to a player. But just thinking about, I mean, personally, I want to play a game like that, where I can walk around in a world that has these very complex quantum things that, like I said, maybe even not feasible to simulate on a classical computer today. I think that's exciting.
Sabrina, go ahead. Yeah.
Yes, and again, I agree with Chris, and I would like also to say that I think generally to try something which is really multidisciplinary, which involves completely new way of thinking, as quantum physics is really always exciting, and then it can give rise to creativity and outcomes that are completely new and original. So I think that very often it's really this bringing together very different worlds that excites also game developers. And obviously, it's also true, and Chris mentioned it also before, as well as James, that the idea of using a real quantum computer, something which is a prototype that we think will be really available soon in the market and revolutionize our society. So a new way of computing. The fact of having access to these quantum computers for creating games that use quantum computers, I think it's very exciting. It's really like a very early stage, and the possibilities and the potential is enormous. So we don't even know what are all the possible applications of games for quantum, but they are tools for brainstorming, for learning, for developing, for creating new things, and also for helping the new industry, which is emerging, I think.
Mm-hmm. And James, any ideas about inspiration or predictions as well there?
Yeah, so what I've been thinking recently is I want to make some quantum software that's worth running and which comes up with useful results for people in the game industry, even if it's not unique, even if you can run it on a simulator, maybe even more easily than a quantum computer. to make some quantum software that's useful to serve as a starting point. And that's something that we've done. We've got a paper out on that, but we've also got a game studio called Mytel, which Sabrina knows well, who are actually using that in a commercial game. So it's not something that's unique to quantum, but it is some quantum software that's useful to someone, which I think is pretty cool. And I feel also I should say that we have devices that are publicly available, and if anyone wants to chime out for games, that's cool.
Uh-huh.
I'd just like to add an anecdote. Sorry.
Mhm.
I just wanted to add an anecdote really quick. So I think getting game developers excited about this, there are things that are traditional game development tools like UI and UX that are very well understood through lots and lots of player testing. But when you start rethinking about these things in the framework of a quantum game, it makes you really rethink how you approach things like UI and UX. And the UI UX developer on the Arkenforge is the game studio that I'm partnered with. When he first saw this game, he didn't seem that excited about it. But when he really started diving into, okay, what does it mean to actually show a quantum state to players, he got really excited just because it was something new for him. He couldn't use his usual toolbox. So I think that's an exciting opportunity for game developers as well, is just being able to really think outside the box on these things.
Mm-hmm. I think what's interesting is, something always needs to drive technology forward, right? If you go back to the 1960s, the semiconductor industry wouldn't have happened if we didn't have a space program, right? And there was no consumer electronics industry back in those days, really, to speak of it. Maybe the transistor radio was around, but today you look at Fortnite and it's got 350 million users. Roblox has 150 million coming every month, and they're pushing technologies like data centers to the limit, right? And cloud gaming or cloud services. And I wonder if gaming could drive this quantum computing from a science and sort of this sort of research level to more commercial enterprises and eventually consumer technologies. Do you folks agree with that? That games may drive this industry forward?
Yeah, I completely agree. I think one of the areas that it could help drive forward is AI. Chess has been a test bed for AI for decades. I could see a future where quantum chess is a test bed for quantum AI, and it helps drive forward quantum AI developments. But I mean, in other areas of gaming as well, I think games are popular and they drive technology no matter what you do.
Sabrina, go ahead. Yeah.
Yes. Again, I agree, and I would like to add to that. We think that something very interesting will be the combination between really human intelligence and computers' intelligence. And in a way, you were mentioning about chess and about, for example, you may think, how will a quantum computer play quantum chess, and how will it play it with a human, and how will it play it with another computer? There are many things that can be thought, but we do know that from the algorithmic point of view, at the moment, one of the most successful examples of algorithms that may have a real-term, really immediate applications, commercial applications, are hybrid algorithms, algorithms that contain both classical and quantum components. And in a way, this hybrid between the human mind and the player and the quantum computer that might be underneath the game mechanics is extremely interesting. It has great potential. And I think it may lead to enormous discoveries, even of fundamental type, I believe.
Now we have about a minute left. Did anybody really want to make another point, or otherwise, add something to the discussion or raise a question here? Yeah. Oh, yeah, James. James, go first. Then. Yeah.
Oh, so yeah. On that last point, I think we've gone in offering devices on the cloud, quantum hardware on the cloud. We've gone from basically, I think, having the lab control systems, but on the cloud and publicly available, and we're evolving towards what is actually required for industry, and games would make things have to happen a lot faster. So it would be a big force transforming that.
All right, Sabrina, 20 seconds.
I have to say, there is another thing we have to mention. Games are fun. And I think this is something to remember when we think about talking about quantum physics, teaching about quantum physics, and everything that can happen in the industry as well.
Okay. We're good. Thank you very much, everybody. I appreciate your participation in this panel.
Thank you.
Thank you.